Hello, my name is Sandy Hood and we're looking at the Financial Management Unit, part of the ACCA Fundamentals, and we're looking at capital investment appraisal. The way to contact me is my email address is sandy@sandyhood.com and my Facebook is Accountancy Tutor. We're looking at a question called Copper Co, which comes from the March-June 2018 sample, and it's a investment appraisal question which involves expected net present values and the calculation of three values with a comment. What do we do? Well, for a question such as this one, which is, I think, question 32 from that particular sample, I recommend spending 45 minutes. This is good practice because you can earn own figure rule marks on section C questions, whereas in section A and section B it's all or nothing. We're looking at the 12 marks for part A rather than the whole question. I would allow 5 minutes for reading the question and then 2 minutes a mark, and in this case there are 12 marks, so 24 minutes. Copper Co is concerned about the risks associated with a proposed investment and is looking at ways to incorporate risk into its investment appraisal process. The company has heard that probability analysis may be useful in this respect, and so the following information relating to the proposed investment has been prepared. Cash flow, probability in year 1. 3 different cash flows, 3 different probabilities. Cash flow probability in year 2, 3 again. But if you were to combine these, you'd find that we've got 9 possible outcomes. The company is not sure how to interpret the results of investment appraisal based on profitability analysis. The proposed investment will cost 3.5 million, payable in full at the start of the first year of operation, what we generally call year 0. Copper Co uses a discount rate of 12% in investment appraisal. We have to produce a joint probability table, calculate the mean NPV, calculate the probability of the investment having a negative NPV, and calculate the NPV of the most likely outcome, and then make a comment. So your exam will be on the ACCA Global spreadsheet, and you should attempt your practice questions using that. It gives you familiarity with what you can and what you cannot do on the ACCA Global spreadsheet. Here's the question again, and now we can move over by looking here. That's my decision tree type of approach, which has told me I'm looking to produce a table which essentially has got 9 different outcomes, possible outcomes, and then I'm going to get the expected value from those. That was our question. And now we switch. So let's get the clock up. And what we're going to do is we're going to put in here the years 1 and year 2. And for these, we're going to have the discount factor, and we're dealing with a discount factor of 12%. And 12% again in year 2. So needing to know what the discount factor is for 12%, we could work it out, or we can just put it in using the formulas within our formula sheet. For 12%, for 1 year is 0.893, and for 2 years is 0.797. Okay. What were our three possible outcomes? Okay, so we could have a net cash flow of 1 million. And I've allowed for 3 spaces there. 2 million or 3 million. And in year 2, we could have a 2 million. We could have 3 million. Or we could have 5 million. And what we can do with those figures is we can just repeat them and repeat them. Oh, if the system is going to allow us to. So repeat and repeat. Why is that going to be useful? Because what we're going to do is we're going to bring together our combined discounted cash flow, and we're going to bring together our combined probability. And that will give us our expected values. So when I look at the 3 possible cash flows in year 1, then the 1 million would convert by 0.893 to 893,000. And I'm going to repeat that. So I'm going to repeat that by going copy and paste. Oh, didn't like that. So let me try again. Copy and paste. And it still didn't like that. So rather than keep flogging away, I'll just go 893,000, 893,000. Here I've got a 0.893 times 2 million, giving me double that amount, 1,786,000. And in this case, I'm using the equals the above to just drag down the figure. Here I've got 3 million times 893, and again equals and above, and dragging it down when I don't make a mistake. There we are. So what do we know about these various probabilities? We've got a 0.1 probability here, and we've got a 0.2 probability here. No, we haven't. 0.5, and we've got a 0.4 probability here. And it's cooperating with the dragging down at the moment. Right. So we're not actually applying the probabilities as yet. We're going to combine the probabilities in a minute. What we do know though is that we've got the 0.797 figure to apply, and that's going to be applied to the cash flows in the second year. And here we've got 3,000 times that cash flow, and we've got 5,000 times that discount factor. Yeah. So those 3 figures, I'm going to copy, paste, copy, let's see if I can do them this time, paste, oh, they don't like that. So this is one of the great values of using the spreadsheet in your practice is that you get the feel of those things you can do and those things you can't do. Okay, so for a slow typer like me, that's been quite handy. What I'm going to do now is I'm going to combine those discounted values, and I'm pretty sure I can drag this one down. So here they go. We've got the 2,487,000, dragging it all the way down. And we've got a combined probability, which is the probability of the first one times the probability of the second one. And here you may have spotted that I have omitted to have a probability column for my year 2. So what I can do here is simply to cut and paste and recognize that there isn't a facility to use add a column or add a row within this particular software. So the chances of a 2,000 was 0.3 or 2 million, and the chances of 3 million is 0.6, and the chances of 5 million is 0.1. Now we were quite lucky last time, we were able to drag this down. We are having to rely on copy and paste this time. Okay, so now we've got the combined probabilities of 0.1 times 0.3, and we've been able to get that in, drag it down, and because we haven't got the we can now go to a certain number of decimal places, and that then helps us. We're now very, very close to our calculation. So the probability brings that in. And what do we do at the bottom? We add them all up. And we know that we've got an initial investment of 3,500,000. So that would give us our expected net present value. So we've got an expected net present value of 865,200. If I look at the clock, that took me 10 minutes. And for an 8-mark question, I would normally have expected to have needed 16 minutes. So I think we can regard ourselves as being pretty much ahead of time. And I'm certainly going to put in here 865,200 and put it into the dollar sign. My second question is calculate the probability of the investment having a negative NPV. Okay, so for that I would be looking at any figures in here which are lower than 3.5 million. So if I put in an if statement, and I say if that figure is less than 3,500,000, then I want to put that or the probability into my column, and if not, I just want to leave an empty cell. So in this particular case, 2 2,487,000 is lower, and so is 3,284,000 and 3,380,000. So those are the three figures which are the ones that are all giving us negative values. So that I know that we've got the probability of an investment having a negative NPV is going to be 24%. The examiner's happy for us to present that as a decimal, and just as happy for us to present that as a percentage. So that's the probability. The third question is calculate the net present value of the most likely outcome. So going down the column, my highest value is 30%. So the most likely outcome is going to be a discounted cash flow of 4.177 million, obviously before we've deducted the initial investment. So putting it in here, 4,177 minus the initial investment gives me a value which at the moment is presented as a percentage, but I've now converted it into the dollars. So what I've done there is I've now completed the first 10 marks of my 12-mark question, and I've done it within 14 minutes. So moving on to part D, I have to make a comment for 2 marks on the financial acceptability of the proposed investment, and the comment would be the expected net present value of the investment is positive. This suggests that the proposal is financially viable. Okay. And then I would say, but decision makers will have to build in their own attitude to risk. There is a 24% probability that the project will generate a negative net present value. That's probably enough for 2 marks. I could go on to say, if this decision is made for several similar projects, the expected value is more useful than for a single project where there are several projects. The overall positive NPV expected will mean that any that are negative are most likely to be more than matched by those that are positive. Okay, and there we have it. It's taken us 17 minutes, and I think we've done pretty well. We'll revert to the slides. That was a short video. We certainly did it well within the 24 minutes that I would have allowed for a 12 marker, and I think it's just my way of showing you how useful it is to work using the ACCA global spreadsheets. Thank you very much for watching this video, and I wish you all the very best.